So this is a National 4, National 5 chemistry lesson relating to rates of reaction. And this lesson is about how particle size, concentration and temperature affect the rate of reaction. What we hope you to achieve from this lesson is to describe how particle size affects the rate of reaction, be able to describe how concentration affects the rate of reaction, and to describe how temperature affects the rate of reaction. So we're going to focus on particle size first. Now, decreasing particle size, what that means is breaking up a solid into smaller and smaller pieces. So that could be, in the most extreme case, taking something like a brick and grinding it up to a powder. That's what we're talking about whenever we are talking about decreasing particle size, breaking something big up into something smaller. Now, as you break apart a solid and make it smaller and smaller, the area or space available at which reactions can happen increases. And we'll get into that in more detail in the next few slides. But decreasing particle size means breaking a solid or compound down into smaller chunks, and the most extreme, smallest particle size is a powder. Now, what effect does this have on the rate of reaction? So we need to know that if a reaction is happening between, say, a gas and a solid, or a solution and a solid, the reaction takes place on the outer surface of the solid. As you break a solid up into smaller pieces, what you're doing is exposing more of the chemical is now on the surface. And that means that because you've got a larger surface area, you've got more places for the reaction to happen. And if you've got more places for the reaction to happen, there will be more collisions happening. Now remember, in order to have a chemical reaction, we need collisions to be frequent and we need collisions to have the right energy. If we've increased the surface area and we have achieved more collisions, what that means is that we will have more frequent collisions and faster rate. So if we decrease particle size, we increase surface area, which increases collisions and increases the rate of reaction. So decreasing particle size increases rate. So here's just an illustration of how that happens. So you can see on the left-hand side, we have got a large block of material. Then in the middle, we've divided it in half. And then on the right-hand side, we've divided it in half again. So we've got 4 pieces. Now what's going to appear on the screen are some ovals that represent the chemical that's reacting with this green block. So when we've got the large one, we can fit 8 possible reactants around the green block. Now if we break that block in half and look at the middle, if we count up how many can fit around it now, it's gone up from 8 to 12. So that means we've definitely increased the number of collisions because we've got more places where that green block can interact with a circle. And now if we divide it in half again, we can fit 16 around it. And so on the left hand side we went from 8, in the middle to 12, and then on the right hand side to 16. If we keep making it smaller and smaller and smaller, the green blocks, smaller and smaller, we can fit more and more of the reactants around it. And that's why the rate increases, because there's more places for them to interact with one another. So if we were to summarize what effect does changing particle size have on the rate of reaction, we would say as particle size decreases, the surface area increases, and therefore the rate of reaction increases. So with particle size, the rate does the opposite of what the particle size does. If particle size decreases, reaction rate increases. If particle size increases, rate of reaction decreases. Now we're going to look at concentration. Now what we're going to see is that if you increase the concentration of a solution, so that's just making it stronger, what you're doing is increasing the number of particles in the same space. And if we have more particles in the same space or the same volume, it means the particles are a lot closer together. So you can see in this diagram that whenever we've got a low concentration, there are fewer particles and they are slightly further apart than in the diagram on the right, where we've increased the concentration and the particles are a lot closer together and there's more of them. So looking at this diagram, how does this affect the rate of reaction? Well, the higher the concentration, the faster the rate of reaction. So as you increase concentration, you increase rate of reaction. Why is this? Well, a higher concentration means more particles in the same space and particles are much closer together. The closer the particles, the more frequently they collide. And as we remember from last time, in order for a reaction to happen, we need collisions and we need energy. If the particles are closer and they are colliding more frequently, we are increasing the collisions, so we will increase the rate of reaction. So if we are summarizing the effect of changing concentration, as you increase the concentration of a reactant, there will be more collisions per second, thus a faster rate of reaction. So concentration is different from particle size. Whatever you do to particle size, the opposite happens to the rate of reaction. But with concentration, whatever happens to concentration happens to the rate of reaction. So if you increase concentration, you increase rate for concentration. If you decrease concentration, you decrease the rate of reaction. And the final one we're going to look at is temperature. And now these two pictures represent a particle that's cold compared to a particle that's hot. The picture on the left is the particle that's cold. A particle that is cold doesn't have a lot of energy, and if it doesn't have a lot of energy, it stays in one place. It doesn't move around a lot. The picture on the right-hand side represents a particle with a lot of energy because it's a high temperature. It's high temperature, it's got a lot of energy, and what that means is that it moves really quickly and it bounces around the room, colliding with so many different things. And that's going to be our underlying understanding of how temperature affects rates of reaction and collisions. When particles are cold, they do not move very much. When particles are hot, they move very quickly. So the effect of temperature on rate. Temperature measures the kinetic energy of particles. By kinetic energy, that means the energy that particles have by moving. If you have a lot of kinetic energy, you're moving a lot. If you have low kinetic energy, that means you're not moving very much. And if you are at a high temperature, you have a high kinetic energy, which means you're moving a lot. If you've got a low temperature, you have low kinetic energy, which means you're not moving a lot. So why does increasing temperature increase rate of reaction? Well, at higher temperature, particles have more energy, which means they move faster. And if they move faster, they're more likely to collide with other particles. When particles collide, they also, because they have more energy, it means the chances of a collision turning into reaction is going to be increased because more of the collisions will have energy equal to or greater than the activation energy. So temperature affects the frequency of collisions and it affects the energy of collisions. So it's really doubly effective at increasing the rate of reaction. If we're going to summarize the effect of temperature on a rate of reaction, we would say as you increase the temperature, there will be more collisions and particles will have more energy, and so they will have a faster rate of reaction. So increasing temperature increases rate of reaction. What we're going to look at now are some questions from past papers and some other questions, all related to these three factors, related to particle size, concentration, or temperature. So this is a recap to deal with particle size. Now what we've said here is when the particle size decreases, something is going to increase, and that's going to do something to the rate of reaction. So we're looking for the missing word or words that go where those lines are. Again, as with the other videos, if you want to write down your answers, you can pause the video to give yourself time to write them down and then just start the video when you've done that. So for this one, what we were looking for is as particle size decreases, surface area increases, which increases the rate of reaction. You could also possibly have said, instead of surface area, you could have said the number of collisions increases, because that's also true. But we were looking for surface area. So this one, again, it's a missing word. Chemical reactions occur when two particles do what together? So the answer to that one is collide. Now really, if you said they bump into one another, you are right. However, the word that we would want you to use is collide, because that is the scientific word for particles that bump into one another. So try and use collide if you're asked this question in the future, if you didn't use it this time. So the speed of reaction depends upon the reaction conditions. Describe how particle size affects the speed or the rate of a reaction. So describe. So for this one, you'd probably want to write 1 or 2 sentences to describe this. So either get an answer in your head or pause the video and give yourself an opportunity to write it down. If you pause the video and rejoined us, what I would hope you would put is something along the lines of, if you decrease the particle size, you increase the surface area and increase the rate of reaction. If you really wanted to improve that answer even more, what you could put in is, if you decrease the particle size, you increase the surface area, which means you increase the number of collisions, which increases the rate of reaction. So putting that extra bit about increasing the number of collisions would take that answer to the best it could be. So this is a past paper question. It's telling us that magnesium metal reacts with dilute hydrochloric acid to produce hydrogen. The equation we don't actually need, because the first question is all we're going to answer. And it says, how would the rate of reaction of magnesium powder compare with magnesium ribbon? So magnesium ribbon is just a solid piece of magnesium that's really thin. And then it's asking, how would the rate of reaction if you used magnesium powder compare to if you used one piece of magnesium in a ribbon? And the answer to that one is that the rate of reaction would be faster or greater if you used a powder and slower if you used the ribbon. So definitely what you want to say is that the rate with the powder is faster than the rate with the ribbon. So we've got another recap question. This time it's about concentration. So it's asking you for when the reactant concentration does something, the frequency of something increases. So there's 2 words we're looking for. So when the reaction concentration increases, the frequency of collisions increases. And then if we have increased the concentration and increased the frequency of collisions, the rate of reaction is going to do something, and the time taken for the reaction to finish is going to do something. What are the missing words? Well, if we increase concentration, the rate of reaction increases, and that means that the time taken for the reaction to finish decreases. Remember that if a reaction is fast, it will finish quicker than if a reaction is slower. Now this one, it's another one where you might want to pause the video and give yourself time to write 1 or 2 sentences down. But this is describe how concentration of reactants affects the speed of a reaction. So for this one, we would be looking for something along the lines of increasing the concentration increases the rate of reaction and decreases the time taken for the reaction to reach completion. You could make that answer even better by explaining why. If you increase the concentration, you're increasing the number of particles in the same space, which makes the particles closer together, which increases the number of collisions. So saying something about collisions would make that answer even better. Here's another question. So we're just going to do question B for this one, but we need to read the start of the question first. So a teacher dropped 0.1 grams of a piece of sodium into a basin of cold water. Now question B says, if the experiment was repeated using ice cold water this time, how would this affect the rate of reaction? So the first reaction was done in cold water. It's asking you if instead of doing it in cold water, you did it in ice cold water, what would happen to the rate of reaction? Well, the answer to that one is the rate would decrease because you've decreased the temperature from cold to ice cold, and temperature, if temperature is decreased, rate decreases. So we've got this final question. So we've got a reaction between marble chips and some acid, and you've got 4 options. Which one of these would not affect the rate of reaction? Which one of those would not affect the rate of reaction? Increasing the volume of acid, decreasing the size of the marble chips, decreasing the concentration of the acid, or increasing the temperature of the acid? Well, the answer is A, increasing the volume of acid. What we'll do is we'll go through the other answers to show that they definitely will affect the rate of reaction. So if we decrease the size of the marble chips, that's going to decrease particle size, and decreasing particle size increases the rate of reaction because there are more collisions. If we decrease the concentration of the acid, that's going to decrease the rate of reaction because you're going to have less acid molecules in the solution and they're going to be further away from one another, so the number of collisions is going to be less frequent. And finally, increasing the temperature of the acid. If we increase temperature of the acid, we would increase the rate of reaction because we would give the particles more kinetic energy. They would move faster, they would collide more often, but they would also have more energy. So more collisions and more energy would make the rate of reaction even faster than before. So that was a video summarizing the effects of particle size, concentration, and temperature on the rate of reaction. Next lesson, what we'll look at is how we can do experiments to measure the rate of reaction and understand that. So I will catch you next time, and thank you for watching.